Hi. Yeah, so before we switch off the lights, yep. Who is using continuous deployment already? That's the only interactive bit, don't be worried. Sweet, so a few, good. Yeah, continuous deployment, sort of cool stuff, but why me? I'm sort of grew up in Austria, lived in Bavaria for a while, worked for one of the sponsors here tonight. United Domains is one of the sponsors here. I was CTO there for a few years, till I decided that Europe's really just not the place for me. Moved to New Zealand about 5 years ago. That's why I have a bit of a weird accent, like German, Austrian, New Zealand mixed up, and I hope you sort of get the gist of what I'm talking about. So yeah, this weird Austrian, Bavarian Kiwi is really, really passionate about startups. So when I came to New Zealand, I discovered that it's really, really straightforward to start companies in New Zealand, and I was totally going for it, and I have a few of them now. And the biggest one is I Want My Name. We do domain name registration, and yeah, I try to just work in that whole sort of agile thing, how you build companies out of nothing and with no money and so on. And we came up with a couple of tools that we love to use, and continuous deployment is one of them, because it just gives us a way to work very, very quickly on ideas and make sure that we actually deliver something and not out bugs that get introduced during our various development endeavors. So why would you want continuous deployment at all, and what is that whole stuff anyway? So the idea of continuous deployment is that every time you have sort of a feature that you think is good enough that the world should see it, push it out there. Try and see if the world is really ready for the whole thing, and do that as often as you can, because new features only mature if they are tested, and you can only really tell if a feature is good or not if you actually get real user feedback. So the shorter the time between writing code and actually pushing it out there, the better it is for you to shape a product in a quick way that is actually what your customers want, as opposed to what your managers want or what you think a product should look like. The other idea behind it is, as a developer, we really are only sort of productive if we do one thing. We pretend that we can multitask. Truth is, we are not really good at it. Not even the women, at least the women developers that I've seen so far. So context switching is something that really just throws us out of our actual thing that we want to do, which is developing. And the other thing that I noticed is with sort of release cycle driven development, where you build a package and deliver a nice thing, and is that whole time is sort of wasted, because your customer is not appreciating a really nice Debian package. That's probably a sysadmin, so they probably totally love you for it, but the customer is not really getting anything out of it. So that whole release engineering gives you sort of a closure to a real feature, and sort of an established way how you can finish off your sprint if you're into agile and things like that. But in a sense of working on one thing and actually delivering a feature, it is not really adding any value. So we try to not context switch. We try to deliver code really fast, and we try to do that in the quickest possible way. And in order to do that, you need a really robust way to roll out code, to sort of push it out there. But it is absolutely crucial that you have at least as good as your rollout procedure, a way to roll it back if just stuff blows up, and it will. But the more robust and the more tested your rollback mechanism is, the more comfortable you feel to just push out code. If it blows up, you know you can roll it back. And that gives you that confidence that you know if you push a feature and 5 minutes later your customer care department calls you, or someone who looks after the support tickets sort of shouts at you and says like, "You're insane, whole thing blows up, whole thing is totally broken, you can't just run a command and it rolls you back to a stage that you know worked. It also takes that whole fear out of releasing code, which can be sort of troublesome to some. If you only release code every month or so, or even worse, I've talked to a guy that he works in a banking institution thingy, and they roll out code like every 1.5 years. So imagine that. If you have a bug in there, it will be there for the next 1.5 years. So that's totally terrifying for me. I roll out code if I develop a lot of features every couple of hours. And there is no reason why I wouldn't, because I know that if stuff breaks, I can roll it back. So the robust rollout mechanism is a really key thing to continuous deployment, but the robust rollback mechanism is equally important. In order to sort of roll out code in a robust way, we used Capistrano for a while, and for those of you who are familiar with the whole Rails toolchain thingy, Capistrano is one of those Rails deployment systems. But if you're not really a Rails developer or a Ruby developer, you sort of get a bit tired every time with the whole thing blowing up on you whenever you install some other Ruby thing that has a different version of a tiny library somewhere. Anyway, one day when it blew up at me again, I sort of gave up on Capistrano and wrote Giovanni. And this lovely saint up here is Giovanni Capistrano, and some Italian dude. Gave a beautiful name. This is roughly how Giovanni looks like. It is very, very similar for those of you who worked with Capistrano. You sort of run geo deploy, it grabs a config, and rolls stuff out. And this is how you configure it. It's a very basic version. You can make it arbitrarily complex. And the key thing about Capistrano, about Giovanni, is it is a Perl way to deploy stuff, which means it is an easy code base. Hack it. Make it fit to your environment. Make it work for you. Giovanni is working for us in the moment. We deploy the whole I Want My Name project completely with Giovanni. But we also have currently about 10 other startups that I'm somehow involved in. And they all use Giovanni as well. One of them uses Capistrano, actually. But all the others use Giovanni, and they have various versions of it. So it has a plugin system. You can hack it. You can obviously fork it. And the key thing about your rollout, if you want to go into continuous deployment, the key thing is that you have a system that you're really comfortable with. So the idea behind Giovanni was to have a Perl way of running that whole stuff in a controlled manner. So one step further, after we have a comfortable way of rolling out code and rolling back code in a really quick way, you can sort of go to the next stage and do that in a more automated way. We love GitHub. We run pretty much everything on GitHub. The thing I absolutely hate about GitHub is I don't have my post-receive hooks. This is why I wrote something that takes post-receive hooks from GitHub and gives me an easy way to mess around with them. GitHublicious is a little Mojalicious app that does nothing else than sitting there waiting for GitHub callbacks, and takes these callbacks, drops them in a CouchDB, and then you can mess around with them. So the post-receive hooks work in a way that every time you push to GitHub, GitHub calls a URL, or can call a URL if you configure it, that gives you the whole meta information about the push that you just did, with all the commits that are in there, with all the latest commit in there that you have something to relate to refer to, all the committers that have contributed code to that push, the whole meta information that you would normally see on GitHub. Large JSON blob, you just throw it I just throw it into CouchDB, and with that I have a very easy way to write notification hooks into, trigger builds, trigger test runs, trigger all sorts of things. So GitHublicious is really just sort of a post-commit hook for GitHub that enables you to fool around with all the data that you get, and also trigger all the release builds that I come to in a moment. To get a bit deeper into the way that whole stuff works or how we've set it up to work is that we normally use a lot of topic branches in Git. So we have typically a whole range of things that we are working on, and we have a master, and the master is our one true thing. And we always work in the topic branches, and the moment we have something that we think is worth, we move it into something that is the one true truth. The important thing when you go into automating your rollouts is that you have to, or at least if you do it with this sort of setup, is you need one branch that is your production branch. We just use master. You can also use a branch called production or however you fancy, but you have to define a sort of master branch that is the truth that you want to have on your platforms. And once every one of your developers is comfortable with it, they're a bit more cautious sort of touching that branch, because everything that hits that branch needs to compile, needs to run, needs to not throw any errors. You also have to sort of agree a bit who is merging what at what time into master. So if you have a larger team, you probably have to coordinate a bit about that. The thing with a master branch is also that I love to push pretty much all the development that I'm doing, at least at the end of the day, into master. If I can't actually release the code yet, I make a little configuration knob for it that disables that piece of code, but still has it in the master branch, so that every other developer that is working on the platform has a way to actually see what I'm working on. Not because otherwise you end up with those monster merges somewhere that totally change the behavior of your platform, and they come out of nowhere, and all the work that you've done for the last 2-3 days sort of is useless because it doesn't merge anymore. So just to avoid that, I try to have the master as sort of bloody edge as possible, and do a lot of actual development work in master, not directly in the branch, but merge it into master every once in a while. The whole configuration knob thing is also pretty key. That's used in a lot of larger setups. Yahoo has done a really good job with documenting how they do that. So every feature that we release normally has a configuration knob where you can switch it on and off. That helps with development. That also helps with running multiple versions of code bases for different target audiences, and also helps you if one of the features require too much resources that you can't handle in a moment. You can just switch off that feature and sort of balance your load with that. So the whole GitHublicious, coming back to GitHublicious and how we run on a commit. In GitHublicious, you can configure a certain branch that it should act on. So one of the key informations that GitHub pushes through in its commit is the branch that the push was applied to. Based on that branch information, we decide if we actually do a rollout or if we ignore the whole thing or if we just notify. That branch information defines if it's a production branch or just a test branch or an integration branch that we don't care pulling out onto the production site. So this is what we currently have as out-of-the-box support for GitHublicious. We have a Jenkins plugin. We are actually moving away from Jenkins in the moment. We have a Giovanni plugin. That's what we're moving towards. We have Jabber and HipChat plugins. We have Git integration only. There is no other version control system that we've considered so far. We have different rollout mechanisms. So we have projects where we have one directory tree where all our stuff lives in. and we have timestamped rollouts where we have 5 to 10 versions of the whole platform or whatever we deploy rolled out into timestamp directories and then linked to a current directory, pretty much how Capistrano does it. That way you can roll back really quickly because all you have to do is setting a link to a different directory, which you can do in the worst case just via SSH on the server. Whereas if you have everything in one directory, you're relying on Git tags. So you sort of have to roll back to the last Git tag, which is equally easy or hard. It's really just a different way to deal with things. And depending on the project, the one or the other may be the better one. But those are all, so the only thing is if you use the timestamped rollout in your rollback, you have to use the timestamped rollback, obviously. Otherwise, you try to roll back to a Git tag, which is not there. So the whole idea about GitHublicious is to really have one thing where it can work in and one thing that sort of gives you all those hooks to play with your commits. What we currently do with Jenkins is that if you push to our production master GitHub branch, GitHublicious triggers a build in Jenkins, and Jenkins runs a test. And Jenkins then deploys with Trani the whole thing to all production servers. So that's all the implicit tool chain that happens behind the scenes. So every time I feel that I have code that is actually good enough to release, I just push to GitHub, and then the release sort of happens implicit. And it only notifies me via my HipChat or Jabber rooms and tells me if everything went wrong or right or broke. And then the monitoring kicks in and checks that, and I go into that in the next step. What we are currently moving towards is that we cut out Jenkins entirely, because all we do there is really just running tests, and for running tests we have a better system in the meantime. And we already use Trani for deployment anyway, so there is not really a big gain we get from Jenkins, and that's why we decided to just ditch it entirely. Anyone using Jenkins? You like it? It's a memory hog, falls over every now and then. Other than that, yeah. So yeah, GitHublicious tries to integrate a bit more testing in the future. That's there for one system we run already, but it's in a very hard-coded way, so we didn't release it yet. We hope that we have that done in the next few weeks. One step further. So we have a rollout system. Now we sort of roll out implicitly via GitHub post-commit hooks. The next step is something that I call continuous testing. Continuous testing is something that I feel very passionate about because it is a different approach to unit testing, which I think is broken, and probably someone kills me for that. Anyway, unit testing or a test run before a deploy really only tells you that in this very moment the whole thing works, which is sort of good to know. Well, you don't want to roll out code that's entirely broken, but it doesn't really tell you anything about code in a complex system that is running, that is probably not running in I don't know, for any sorts of reasons that you don't control. A large system is normally made up from a little sort of front end, you have a back end, you have a couple of APIs that you hook into, you have databases that rotate around the edges, and you have all sorts of bigger things that you either control or not control. So the tests we started to write for I Want My Name are really only front-end tests. So we have a complete test suite that goes in different user stories across the whole site and clicks every button and intercepts all the responses that we get back, and tries to make sense out of did we actually get the right response from the backend that we are talking to? Is this registry still up? Did we really get the notify that we want from our DNS backend? So the whole tool chain, and not just is this library behaving as we defined it, because this library may work wonderfully, but the API it hooks into is broken, or it doesn't play with the rest of the system. So unit testing has its total rights, but in a big application, I think functional testing from a user's perspective is way, way, way more valuable. And it doesn't change that much. So you only have to write new tests for new functionality, whereas if you have only unit tests, the moment you throw away a whole library, you also throw away all the tests with it, and you write new tests, and the new tests probably or hopefully cover all the edge cases that you had in the old one already, but you still don't test the integration in the whole app. Whereas if your front-end tests work, it is unimportant if the library has a different interface or behaves in a completely different way, as long as the entire system is behaving in the same way. And we really noticed that a lot of stuff just breaks over time. It worked perfectly now, but 3 months down the track, for some odd reason, it starts to break. So continuous testing is the idea of running your test suite every sort of 5 minutes or even every minute across your entire system. And this has a couple of side effects. First of all, you can tell at any given time that your platform is working entirely. The other thing is it generates load. And as stupid as it might sound, generating load is actually a good thing. It makes sure that all your systems are actually hot. They're working, they're there. If stuff breaks, you get notifies right away. And also if you have load spikes, and you probably need to spin up more instances to sort of accommodate for that load spike, you can always switch off your tests, which buys you another couple of minutes to bring up all your new systems. And once you have up all your new systems running, you can sort of switch them on again and generate that artificial load, which just bought you those few minutes and hopefully rescued you from throwing too much errors and stuff.
Are you testing in production?
Yes, we run those whole test suites against production, definitely, always. I scared someone, I'm sorry. Oh, cool. Yeah, if there are more questions, totally just ask me. I'm used to that. That's how Perl as Wellington works. Everyone's just shouting at me, shouts me out. So yeah, all the tests run against production. We have monitoring users, we have monitoring credit cards and test modes and things that we can trigger, but the production platform is what we run our tests against. The I is something that I wrote a couple of years back to run continuous testing. And it really is sort of a tap parser, tap thing that just runs tap tests and outputs a couple of graphs and yells at you if the stuff breaks. So I call it test-driven monitoring. It is a very, very easy thing. All you have to write is tap tests that either crawl your site with Mechanizer or we actually started using Phantom.js recently. A couple of friends of mine in Wellington wrote a Phantom.js library that does tap output, so we can just run it with normal tap parsers. And yeah, and then you just run the I, and the I runs all the tests in the test directory, times every step of the test, and generates RRDs. And with those RRDs, what you get out of the additional graphing step is that you see how your platform behaves over time. You see which code changes impacted higher or lower response times for certain functionality. You see pretty clearly, if you overlay a traffic map, you see which functions start to degrade or get slower if you have more users on the website. So you get a lot of really, really useful metrics out of that. The notification bit is currently pretty primitive. It just triggers prowl messages if things are not behaving as they should. Well, basically if tests throw a not okay or timeout. We're working on integrating that into GitHub to run the tests with the I. And also display all the graphs in GitHub so that you have really one command center sort of where you have a full view of your whole project. Yeah, running the UI is really simple. The whole continuous testing approach is something that gives you a pretty confident view on your platform because we run it in production. We know at any time that the platform is behaving as it should, and so we have the key user story we have on our side is, can a customer buy a domain and check out? That was the first test we wrote. Because if that's given, we can be sure that we can make revenue, which ultimately helps everyone because we can provide a platform that actually is working. And the next user story was can someone actually manage their domain? And from there, we grew all the tests to the stage where we now have a couple of more JavaScript-heavy parts of the website that we test with Phantom.js to just make sure that, yeah, JavaScript is always heavy to just test with Mechanizer. It's always a bit messy. Phantom.js is a very good solution for that. So yeah, this whole giving you peace of mind that the whole thing is working in an expected way, and also if it breaks, that it tells you where it breaks, and so you get the exact test that broke with the whole debug output as a problem message, and can act on it, hopefully. So what we currently support is any tested outputs tab. Since we have this Phantom.js library, we can run Phantom.js, test the Mechanizer tests or anything you really like to spider your website and sort of find out if stuff works. Problem notifications. We have Graphite support as well, not only RRDs. We use Graphite in the meantime. RRDs are simpler if you only want to display them. Graphite is nicer if you want to collect more stats from CollectD or other parts of your system and have one sort of central graphing engine anyway already. Pretty quick. Summary. So one thing that I think is absolute key if you're trying to get into a more quick way of deploying stuff is that you automate really everything. Don't waste time, don't repeat yourself, don't do things over and over again. Automate as much as you can, even if your sysadmins hate you for it. Automated deployments are really cool. They lose control over when they roll out code, but if the rollout procedure is a robust one, they don't need to know when you roll out code. In larger setups, you can go to a time-based rollout, so that you roll out every 15 minutes, for example, or every half hour. I think Yahoo is currently rolling out every 5 minutes, or Amazon, one of them. So if your company is bigger than the startups that I'm working in, probably go for a time-based rollout mechanism rather than a post-commit hook-based rollout system. But the mechanics behind it are the same. You really always have a robust rollout, a robust rollback, a test stage in between, and that's all automatable. That's no manual intervention. The less humans you have, the less errors you normally have. Notify a lot. We write loads of Jabber logs. We write loads of notifications through all sorts of channels. And that gives you a very transparent view of what the bots are currently doing, which is sort of, if things go wrong, you can trace very easily who has triggered something. That comes back to whoever releases code is the one who owns it. So if I release code and it breaks stuff, I'm the one who has to fix it, and I'm the one who has to clean up after it. So that's the whole code ownership that you enforce with a notification mechanism that shows publicly to everyone who did the push, who did the commit, which commit triggered a rollout, and sort of make sure that you really make that visible in a way that everyone's aware of it. Avoid context switching, by all means. Really try to work on one thing. Really try to concentrate on the one thing. Make as many steps as possible implicit, so not something that you have to run explicitly. Like the Trani thing is really just a start. It's only the mechanism behind it. You can run it explicit if you want to, but run it implicit is a way smarter way of doing it. Questions? Yeah.
How often did you break your front end?
Oh, lots of times. The thing is, you don't really piss off customers if you recover really quick. And breaking a front end is also a pretty relative term because you really rarely fuck up the whole system. You normally fuck up something small for some customers. So breaking the entire system is something we haven't done for a long time. But breaking it for some happens. Totally does. Yeah?
How do you deal with the changes in the database schema? How do you apply such changes onto production database, and how do you roll back them if necessary?
We cheated. We don't use relational databases at all. We use CouchDB and Redis, and there are no schema changes. All you have is views, and we apply views in the same way. We roll them out, we can roll them back. But we don't have to roll them back, actually, because we just add new views, and some went clean up, the old ones. In a relational database world, there are ways that you can apply schema changes in a way, but I'm no pro on that front, really not.
Regarding the database schema change issue, one thing that continues to point to consider is a book called Database Refactoring by Addison Leslie. It gives a lot of excellent examples of how you can push out a schema change first in such a way that it's completely backwards compatible, and then you follow that up with the code change. So even if you have to roll your code back, you don't have to roll back your schema change. It makes it a lot easier.
Sweet. That's your answer. Yeah.
How do you define what happens for an individual project when it's being built? How do you customize a build A for this project? How do you send it out? In what language? How do you
It comes back to this one. Not this one. This one. You have deploy steps. You have update cache, restart, notify, and you can have as many steps in here as you want. There is also post-push hooks in the meantime, so that after you pushed code, you can run a compile step. We deploy Erlang with that. We deploy Node.js stuff with it. We deploy Perl with it. So we have things where we have to restart web servers. We have stuff where we have to compile stuff on a server. And you basically write scripts and then call them in the steps where they have to run. And all that, so the deploy steps are always run on the actual nodes and on all of them, so in parallel. Yeah?
How much of a test environment do you maintain? And do you have a complete copy of
Yes.
prod?
We have a complete copy of prod that runs all the backends. We run all the tests there. And then if that worked, we roll out to production. And CouchDB makes it really simple because it has a very robust replication mechanism. So every once in a while, we just replicate the production database into the test system and have a complete replica. Yep.
If you do rollback, do you also revert changes in Git, or do you
No.
just
No. Hell no. Git is untouched. We only roll back the code base to give the customer a working platform. That's all we are concerned about. We're not concerned about cleaning up anything that the developer fucked up. That's up to him.
So does it automatically on the next push then redeploy, or do you have to manually?
Yeah. Next push redeploys. So you fix your changes, you test in your local test environment, you run through a regression test, you probably write a test for it to cover that point. Once you've done that, you go through the whole release cycle again. Behind that? Yeah.
If you use the production database as a copy for your testing environment, do you have some sort of an idea on how to do that in Germany? the government would like run all over you because you just can't use production data.
We live in New Zealand. It's heaven.
For example, want to comply to the PCI stuff, then you just can't do that.
Well, we don't have credit card data in there.
Okay, do you have any advice on what you could do instead?
Anonymize the data. If you export your data, run an anonymizer across it, or just shuffle your data. By all means, please strip out your credit card data. Don't store it anywhere. If you store it, just don't mention it. And make sure that you sort of just anonymize your data in a way that it is all scrambled up and can't be traced back. Yeah.
Do your tests in production create data?
Yes, they do.
How do you avoid that from blurring out statistics?
By making them predictable, that we can filter them out again. We had an interesting case for that exactly there with testing via PhantomJS, and PhantomJS normally just comes up as a WebKit browser, so it messed really badly with our Google stats, whatever the analytics, that was the one. So we set an actual user agent, and now we can filter it out again. So just make sure that all data that you push in and generate with your test is predictable, so that you can filter it out for all the analytics that you're trying to gather from the platform. One more?
If someone pushes a change which breaks something and you have to roll it back, what happens if the next developer pushes something which also triggers a release? You've got the rollback code, but presumably the new code will have a breaking result.
Notify, notify, notify. The moment something breaks, everyone has to know it.
But do you stop any kind
No.
of releases?
No. Shoot yourself in the foot, you're totally welcome. Everyone's his own, everyone has to deal with his own destiny. If you inherit broken code, find the developer who broke it. That comes back to code ownership. If you push something and break the platform, you're the one who has to fix it up and clean it up and make sure that you do in a timely manner, like now would be good. And that ties into also probably letting, if you know someone else is about to deploy, letting him know, hey, actually I broke stuff, if he didn't notice already. But because we use Jabber notifies and we have a special log channel where all our development discussions happen, all our bots log into the same channel, so we actually normally know what's going on before we deploy.
You should mention that we have 2 developers at the moment.
Yeah, we also just 2 developers. Well, Timo is developing as well, and we have 2 more for the front end, so we are a bit more, but we are 2 main core developers, and it's pretty, but we are, like Toby is in Germany in the moment, and I live in New Zealand normally, so there is some things that only happen via Jabber. You can't just tell them like, shut up, don't roll out now, because he wouldn't listen because he's way too far away. Good. I think we ran out of time, did we?
1 minute left.
One question for a minute? We're fine. Oh, sorry.
It's not cost you a lot to register domains all the time. When you're testing on production server, you've got to find the domain every half hour or so.
Sorry?
You're testing on the production server?
Yeah.
And you're registering domains?
Yeah.
Does it not cost you a lot?
And we have filters that detect that it's a test registration and push them into the OTE system.
Right, cool.
Yeah. We also do the same thing for credit card transaction. We don't actually do credit card transactions. We push them into the test system of the credit card provider. That was the 1 minute question. Cool.